I have a box, also including 27, 27 socks. They are four tan color, seven brown color, and five yellow color, and also 11 blue, 11 blue color. Assuming I am blind folded, so I am blind folded. First of all, let's try to figure the smallest number of socks I need to pick to guarantee I have two socks of same color. So first of all is let's try to figure smallest number of socks I have to pick to be absolutely certain. So I have two socks of the same color. So which color? So it's really doesn't matter. But I need two socks of the same color. So let's see how to solve this kind of problem. And definitely you need to understand the strategy to solve this kind of problem. So when you solve this kind of problem, always think about the worst situation. So imagine in the worst situation, you can do something. That means what? Definitely you can do that things in any situation. That is the strategy behind this kind of problem. So also you can think about as you have so bad luck. So basically, you want to try to pick something. So you cannot pick until you have to pick. So use those kind of idea. So definitely help you understand this one. So for example, as you might feel, the smallest number of socks I need to pick is nothing but two socks. For example, I get two brown. So basically, I pick one brown and I pick another brown. Basically, I get two socks, but so I already get two socks of same color. If you think about that direction, actually is what? That means you are super lucky. It definitely is not in the worst situation. So definitely is answer not two. For example, so if you pick one is a tan color, another is a blue color. You pick two socks, but clearly they are not of the same color. So again, to solve this kind of problem, always think about the worst situation. Always assume you have so bad luck. You cannot pick that one until you have to. So first one, you pick a 10. So you pick 10. You have bad luck. That means what? You cannot get same color. Assuming next one, you get the different color, which is a brown. Which is brown. So continue. You still have bad luck. That means next one, you get a yellow. So still, not two of the same color. So next one, still, bad luck, you pick one blue, so that's very clear. So if you choose those four different color, you pick four, but you still have no two socks of same color. After you finish those four, actually, so it really doesn't matter. You pick which one is the next color. So basically, one, any color. So definitely you will end up with two socks of same color. So that is the smallest number of socks. Guarantee you will have two socks of same color. That means answer is nothing but 5. So try to understand what is a strategy to solve this problem. Smallest number of socks. So you have to pick to guarantee to have two yellow socks. So if you understand the first problem, so of course, definitely you can easily understand the second one. Always think about the worst situation. The goal is you want to get a yellow color. Of course, so you have so bad luck. You cannot get a yellow until you have to. As you imagine, the first one, you get a 11. 11 socks, but it's a 11 blue. So you already get a 11, but definitely it has nothing to do with the yellow. So next one, I'm going to choose this number. So sigma, you choose another 7 socks. But they are brown. So definitely it's not yellow. So next one, of course, you choose another 4 space 4. But they all tan color. So imagine, so you choose 11 plus 7 plus 4, which are 22 socks. So now still has nothing to do with the yellow. But after you choose those 22 socks, so now you have no choice. You have to pick a yellow. Of course, next one, you pick one yellow and pick another yellow. So basically, pick 2 more socks. Those 2 socks must be yellow. of course, that should end up with the final answer for this problem. Again, for this problem, always think about the worst situation. Always think about as you have so bad luck. You want to get something you cannot get until you have to. So that's why the final answer here is nothing but those four numbers added together. So final answer is nothing but 24. So make sure you fully understand so this problem. So let's see, let's try to figure so what is our smallest number of socks, you have to pick to guarantee include 310, three brown, and then three yellow, and three blue. So let's see how to solve this problem. Definitely something much more complicated than the first two. First one, I will give you as a wrong answer. So you choose 4 socks, but definitely is not reach our goal. You choose another 7 brown, definitely is not reach our goal. So of course, next one, you choose 5 yellow, so definitely is not reach our goal. And of course, you have to choose so at least 3 blue. That means what? After choose this one, we will end up with at least include 3 10, 3 brown, 3 yellow, and 3 blue. That means what? Your answer is nothing but 4 and then plus 7 plus 5 and then plus 3. So actually, if you do this one, of course, your answer again is nothing but equals 19. Actually, 19 is definitely wrong. So makes sense, but definitely wrong. I will quickly give you one example here to understand why 19 is a wrong answer. If you pick 11 blue and then plus 7 brown and then plus 1 yellow, you get 19, but definitely is not satisfied this condition. That means what? This is a wrong answer. So make sure you understand. So this is a wrong answer. Let's see why this is wrong. So if you choose this way, actually, this answer still means so you choose not the worst situation. So the worst situation is what? You choose a lot of socks, still not satisfy this condition. So I do notice this number is big. So look at here. We have 11 blues. That means what? Definitely is if you choose 11 blues, you choose 11 socks, but only as one color, only one color. So that means what? So definitely is that means this is a super bad luck. So that is something so you need start with. So instead of start with this direction, I'm going to every single step I choose a larger number. So for example, so first step is you choose 11 blue. So clearly, you already choose 11 socks, but only including this color. So definitely that means what? That means it's not good luck. So next one is I do notice this number is so big. Let's try to use this number. Of course, next route you pick 7 browns. Of course, after you choose 7 brown, now you end up with 18 socks, but still only including 3 blues and 3 browns. Of course, we need match all those 4 conditions. So next one, I do notice this number is big. That means for definitely you want to try so pick 5 yellow. So 5 yellow, of course, still you have so only 3 colors. Next one, of course, at this point, now we have no choice. So of course, after you choose all those 3 colors, so next one, all we need is 310 color. Now, of course, we have at least 310, 3 yellow, 3 brown, and 3 blue. Of course, add together, that should be our final answer. Of course, this give us what? This give us 8 plus 7, which is 15. Of course, add together with 11, that give us nothing but. Final answer here is nothing but 26. That is answer for this one. Make sure you understand. So if you choose 19, that means what? You're still not using the worst situation. I will quickly give you one example. So imagine the first figure is a circle. So next one is a square. And then followed by a star. And then circle, square, and then star. And then of course, and then star repeat. Let's try to figure the 100th of figure. So basically try to figure what is the 100th of figure. So definitely is what? This is a repeating pattern problem. Because what? Because we do notice after 3 figures, it's the repeat. They tell us this is a repeating pattern problem with a cycle of 3. So after 3 figures, it start to repeat. Always remember, identify the repeating pattern with a cycle of what? That number is super important. Once we identify this as a cycle of 3, all we need is use this number and it divided by the number of cycle. Of course, that give us 100 divided by 3 is nothing but give us a remainder 1. Always remember, focus on the remainder. Don't worry about that quotient at all. Because what this is a repeating pattern problem. If you end up with 33 remainder 1, what that means 33 cycles. You can totally ignore that 33 complete cycle there and focus on the remainder. So that is something you always understand. So next one, of course, you try to figure, so another number divided by the number cycle give us 8 the same remainder. For example, we know 4 and it divided by 3, so definitely give us the same remainder, of course, remainder 1. Of course, we even know 1 divided by 3 is also give us what? Also give us a remainder 1. So always remember one super important property about this kind of problem. If the numbers divided by number of cycles give us a same remainder, that means what? They point at the same answer. So always remember this one. So same remainder, we divide by what? We divide by the number of a cycle, or the number of a cycle. So that means what? That means they point the same answer. They point the same answer. So always remember this one. This could be so super useful here if you understand. And solve this kind of problem. So we do notice 104 and 1 divided by number cycles 3 give us a same remainder. What that means? That means a figure 100 must be same as the figure 4 must be same as the figure 1. So it's very clear. This is our first figure. This is our fourth figure. It's very clear. Figure 4 equals the figure 1. So that definitely clear. You understand why those two give us same answer. So now, of course, we are ready to figure our final answer. So figure 100 must be same as the figure 1. That means what? Answer is nothing but a circle. That's how you understand this one. So I'm going to quickly put down so the first problem. So imagine I have 6 numbers. So basically from 1 to 6. So first one, Jack picks a number at random. And then Jack keeps that number. Keep in mind, this information is super important. So after Jack pick one and keep that one. So now next one, Peter pick another one. So Peter, so now pick one number. So at a random. So let's try to solve. So what the probability? The product of those two numbers is odd. So what the probability? So we end up with the product is odd. Let's see how to solve. So this kind of problem. So definitely something super common. So try to fully understand. So actually, this information is so important. So Jack pick one, but keep that one. So what that means whatever Jack picked. So that number, of course, Peter cannot pick that one anymore because what? Because Jack already keep that one. So when you see this one, that means what? This is nothing but means without a replacement. So in the future, so if you see without a replacement, so what that means it's nothing but so someone pick something at random and they keep that one. So don't put it back in. That means what? This is without a replacement. So always remember. So that is how to understand without replacement. Now let's try to solve this one. Let's try to list all the possible answers. So after you solve this one by listing all the possible answers, of course, in the future, definitely we understand much better. We don't need to repeat this process anymore. Jack's number is the first one. Of course, next one is a Peter number. So let's try to pair up and let's try to list all the possible ones. Of course, Jack number so could be 1. So if Jack number is 1, definitely is 1. Peter number cannot be equals 1 anymore. That means what? Peter number could be 1, could be 2. Of course, could be 1, could be 3. Of course, could be 4. Could be 5. Of course, could be 6. So continue. How about Jack number is 2? Of course, clearly Peter number is anything but not 2 because what? So Jack keep that 2. So that means what? Could be so 2 1. Of course, could be so 2 3. So of course 2 4. Of course 2 5. And then of course 2 6. So continue. How about first number is 3? Of course 3 1, 3 2, not 3 3. Of course could be 3 4. Of course 3 5. And is 3 6. So next one, of course, how about first number is 4? Of course, could be 4 1, of course, 4 2, 4 3, definitely not 4 4, of course, 4 5, add 4, 6. So continue. How about first number is 5? Of course, could it be 5, 1? So 5, 2. So 5, 3. So 5, 4. Not 5, 5. It's 5, 6. So continue. How about first number a 6? Of course, could it be what? Could it be 6, 1? Of course, 6, 2. So 6, 3. So 6, 4. Of course, 6, 5. So definitely not 6 and 6. Because what? Because this is without a replacement problem. So now if you count, of course, we definitely end up with what? Total outcome is Nasiba, so 30. We figure, so total number of outcomes is Nasiba equals 30. So actually, after list those 30, so now definitely we understand why we end up with 30. Because what? Because this is Nasiba, a multi-step process. So sigma, this is our first step. This is our second step. It's very clear. So first step, we have what? We have 6 weeks because Jack number could be so 1, 2, 3, 4, 5, and 6. So therefore, first step we have 6 weeks. So how about the second step? Because what? Because Jack pick that number and keep that one. So what that means? That means the first number definitely what? Cannot be so the second number anymore. Then that means what? In the second step, we have only 5 weeks. We have only 5 weeks. Of course, multiply together is a Nasiba, so 30. So try to fully understand this is a multi-step process. Again, so if you have trouble understand this is 5, of course, you can always try to pick one valid answer for the first one. So for example, Jack number definitely could be 1. If Jack number is 1, of course, how about Peter number? Of course, definitely could be 2, 3, 4, 5, 6, 5 weeks only. Of course, that's why we end up with 5 weeks for the second step. So that is a very common strategy. We try to figure so number of weeks for the multi-step. Try to figure so product equals odd. So keep in mind. So at this point, definitely is unique sigma, the parity property. Because what? It must be so odd number any times odd number. Of course, odd number times odd number that give us an odd product. Of course, you can always check one by one. So for example, of course, first number is odd, and the second number is also odd. Of course, I see 1, 3, and 1, 5. If first number is even, no way we get odd, so product. So how about first number is odd number? Of course, could be this one. Of course, could be so this one. So basically 3, 1, 3, 5 definitely works. So how about first number 4? No way. How about first number 5? Of course, could be 5 and multiply with 1, and 5 multiply with 3. If first number is 6, definitely doesn't work. After we check one by one, we do find there are 6 minimum conditions. Base one is this one, this one, this one, this one, and this one, this one. We figure minimum condition is Nasiba, so 6. So let's quickly figure out why we end up with 6. So because what? In the future, so I really don't want to list so all those possible 30 outcomes here. So definitely take why. If you understand so why we end up with 6, definitely you don't need to do this one anymore. So sigma, so in order to get our product, first number must be our number. Let's try to figure out first one has how many weeks? Of course, could it be 1, could it be 3, could it be 5, and this one. First step, we have 3 weeks. In order to figure out a second step has how many weeks, of course, you can always assume so a valid answer for the first number. For example, first number is 5. So imagine first number is 5. Let's try to figure so how many weeks for the second one. So clearly, this is what? Without a replacement, that means what? We cannot have 5 anymore. We can only have 1 and 3. That tells us what? We have only 2 weeks. We have only 2 weeks in the so second step. Of course, 3 times 2 is Nasiba give us what? A Nasiba give us 6. So now we are ready to solve this problem. Of course, final answer here is Nasiba, so 6 over 30. So simplify, divided by 6. That gives us final answer here is Nasiba, so 1 over 5. That is answer for this one. So make sure you fully understand this one. So still I'm going to keep everything same. So I'm going to change the last problems only. So sigma, we still have 6 number. So 1, 2, 6. So Jack pick 1 at random, and Jack keep that base one is Nasiba without a replacement. So of course Peter pick 1 at random. Let's try to figure what the probability sum is odd. Let's try to figure what the probability. So sum is odd. Let's see how to solve this one. So definitely first step is we try to figure, so this is nothing but a multi-step process. So sigma, we have two numbers. One is for the Jack number, of course, Jack number. So next one is for the so Peter number. Because what? Because we needed two numbers. So that's why each number is nothing but one step. Make sure you understand this one. So Jack number definitely is we have 6 ways. So could it be 1, 2, 6? So how about Peter numbers? Because it says without a replacement. That means what? Jack keep number. So whatever. So Jack picked. Next step we have 5 ways. If you really have trouble, you can always after you figure out the first step. So assuming Jack has a number, for example, Jack definitely can have 5. So if Jack has 5, definitely is Peter number could be 1, 2, 3, 4, and 6. I clearly give out 5 ways. Then here you understand why this says 5 ways. Of course, multiply together is nothing give us what? Is nothing but give us 30. So total outcomes. So next one, let's try to figure minimum condition. Clearly, we want to use a parity property in order to get odd sum. That means what? Definitely is the first case is what? Is nothing but as odd number and it plus an even number. Of course, next one is so how about first number is even, second number is odd. So clearly, again, this is nothing but a multi-step process because what? Because we need two numbers. That means what? Each number is nothing but one step. So try to fully understand the difference between step and answer. Let's see how to figure so number ways for this one. First number is odd. Of course, could it be what? Could it be 1? Could it be 3? Could it be 5? So that means what? First number, so we have 3 ways. Clearly, this is a principle of multiplication because it's a multi-step problem. So next number is even. So of course, let's assume so first number is whatever odd number. For example, first number is 1. Let's try to figure, so next number is even. Of course, next number could be what? Could it be 2, 4, 6? So still we have 3 ways. So that means what? Second step, we have 3 ways. Multiply together is nothing but 9. Of course, if you understand the first one, so definitely we can either figure, so the second one, clearly our first number, we have 3 ways, basically 2, 4, 6, that give us 3 ways. Let's assume first number is nothing but 6. Let's try to figure second number is odd. Of course, could it be 1, 3, 5? And that means what? Definitely we still have 3 ways. Of course, multiply together is 9. Case word, that give us what? Add together is nothing but 18. So now we are ready to solve this problem. Of course, total is nothing but 30. Minimum condition is 18. Let's simplify this one, divide by 6. That give a final answer here is nothing but 3 over 5. That is answer for this one. So make sure you fully understand this one. So I'm going to change so this one. In the last 2 example, Jack pick 1 and keep the 1. How about Jack pick 1 and he put it back? So put it back. So you mentioned so and he put it back. Of course, this situation we call this as with a replacement. So with a replacement. With a replacement basically means what? A person pick 1 and then put it back in with a replacement. That is how to understand this one. Let's try to still solve what the probability. The product is odd. Let's try to see the huge difference from the first example. Actually, for this problem and the first example, the only difference is here. So basically, here is with a replacement. The last one is without a replacement. Let's see how to solve this one. Again, we need 2 numbers. So first number is so Jack as numbers or Jack's number. So next one is Peter as number. So Peter number. So clearly, this is nothing but a multi-step problem because we need 2 numbers. Each one is nothing but 1 step. So first step, of course, clearly we have 6 ways. So because what? Because Jack put back in whatever. So he picks what that means. That means Peter can still pick any number from 1 to 6. Now, of course, and nothing but still we have 6 ways for the second step. Of course, multiply together is nothing but equals what? Is nothing but equals 36. Clearly give us what? Total outcome. Let's try to figure minimum condition. So minimum condition is odd product and nothing but give us what? Is nothing but give us only one case work, which is odd times odd is odd. So clearly this is a multi-step process because what? We needed 2 numbers. So let's try to figure how many ways for each step. First step is our number, of course, could be 135. So clearly we have 3 ways. So how about second one? Because so Jack pick one and then put it back in. That means what? Second number still can be any. So any odd number. That means what? Still could be 1, 3, and 5. That means what? We still have 3 ways to minimize this. After you figure the first step, assume a valid answer. For example, the first number is 1. Because Jack pick one and put it back that 1. That means what? In the bag, still we have 3, so 3 odd number, which is 1, 3, 5. That means what? Definitely we still have 3 ways in the second step. Of course, multiply together. Of course, this is Nasiba equals 9. So now, of course, we are ready to solve this problem. It's very clear. And Nasiba 9 over, so it's 36. Final answer here, and Nasiba as 1 over 4. As you may already notice, this problem is very similar to what? It's very similar to the dice problem. So next one, I'm going to change this problem a little bit. So what probability? So sum is odd. Sum is odd. At this point, definitely you may already guess answer right. We know answer is half because what? We know this problem is exactly the same as the dice problem. That gives us a total outcome is Nasiba 6 times 6. Of course, that gives us 36. In order to get us odd sum, of course, we know it's even and it plus odd, or odd and it plus even. Of course, even plus odd. Of course, first number is even, could be 3 ways. So next number could be odd, of course, is 3 ways. Of course, multiply together is Nasiba 9. Of course, here is Nasiba 3 times 3, which is 9. Of course, that gives us what? That gives us minimum condition is Nasiba 18. Of course, that means what? Probability is Nasiba 18 over, so 36. We end up with answer as half. The problem says radius of circle decreased by 50%. Let's try to figure the percentage decrease of the area. So of course, let's see. So already circle with a radius, let's call this R. So new circle radius is what? Is decreased by 50%. Let's try to figure the new radius. Because radius is decreased by the 50%. That means what? The new radius is Nasiba. As R multiplied with 1 minus 50%. It's very clear. Give a Nasiba, of course, half R. Of course, you can write this one in Nasiba. So 0.5 R. That gives us the new radius is Nasiba. So 0.5 R. So of course, we can either figure the area for the older one, of course, Nasiba pi R squared. So how about this one? Very clear. Nasiba pi, of course, new radius squared, Nasiba 0.5 R, everything get squared. Of course, simplify here, Nasiba 0.25 pi R squared. So now, of course, always try to figure out the percentage decrease. So always remember the percentage decrease formula or percentage increase formula. Nasiba talk about percentage change. Of course, the formula is Nasiba try to figure a change between those two numbers and it divided by the original one. So difference you need. So remember this formula, very, very common. You need difference, remember. Change and Nasiba the difference. Of course, this number is bigger, of course, this number is small. Let's use so pi R squared and then minus 0.25, so pi R squared. Of course, original one is Nasiba pi R squared. It's very clear. Top and bottom one, they all have a pi R squared, pi R squared, pi R squared. So definitely, as you may already notice, the best way for this one is Nasiba pretend some number. So let's finish from here. It's very clear. This one minus 1. Of course, you can factor pi R squared out. It's Nasiba 1 minus 0.25. Of course, and then divided by pi R squared. Of course, we do notice pi R squared cancel. That gives us Nasiba 0.75. Of course, change to a percentage, and Nasiba 75%. That is answer for this one. Again, you may already notice the pi R squared eventually cancel out. That's why definitely is you can pretend some numbers. Of course, you can pretend original number R is 2, the new R is 1. Of course, at this point, you can pretend this number is 100. Of course, this number is nothing but 25. You can pretend this is from 100 and to 25. Assuming you set pi r squared equals 100, it's very clear. A nothing but from 100 to 25. What is a percentage decrease? Very clear. A nothing but 75%. That's how you solve this one. Try to figure the was digit. So was digit of 3 to the 2015 power. For this kind of problem, so definitely you need to understand this one must be a pattern problem. So you figure that result and try to figure what is the was digit. So the was digit clearly must have some pattern. Otherwise, definitely this is super bad problem. So let's see how to figure out the pattern. Of course, clearly depends on the power. So let's try to track the power and also the was digit for that particular power. If power equals 1, it's very clear. Was digit is nothing but 3 to the first power is nothing but 3. If power equal 2, it's very clear. Give us 3 get a square is nothing but 9. How about power is 3? As of course, 3 get a cube is nothing but 27. Of course, we pick 7 here. You may already notice, of course, this number is nothing but try to multiply with 3 and pick the was digit. Of course, next one is power 4. It's very clear. 7 times 3 is nothing but 21. Pick the was digit and nothing but 1. So next one is 5, of course, this one multiplies 3 is nothing but 3, of course, continuous 6, of course, 9, and of course, at this point, it's very clear. So this is nothing but a repeating pattern problem. So after power 1, 2, 3, 4, of course, we think answer is nothing but 3971, 3971. So now you sigma the problem I just put out there. So sigma is what? This is our the index of the figure. So figure 1, figure 2, figure 3, figure 4, figure 5, figure 6. Of course, 6 plus 3 is what? 3 is a circle, 9 is a square, so 7 is a star, so 1 is oval. Of course, now clearly is what? So star repeat, so circle, square, so star, and the oval. It's very clear. So it's nothing but a repeating pattern problem. So now, of course, if you still have trouble, sigma is nothing but, of course, so circle, square, so star, oval. This is our figure 1. Figure 1 is what? Is corresponding to the power 1. So sigma is 1 is a figure 1, 2 is a figure 2. Of course, now problem try to figure out. So power is 2015. It's nothing but try to figure 2015's figure. So it's very clear. So now the problem is 8. That is it. So if you get here, of course, a nothing but try to figure number of cycle. It's very clear. A nothing but also cycle of 4. So of course, 2015, and then divided by number of cycle. Of course, get a remainder is nothing but 3. So what that means next step is try to figure which number divided by 4 give us a same remainder. Of course, the easiest one is you can think about 3 and then divided by 4. So definitely give us a remainder 3. So keep in mind, numbers are divided by the number of cycle. If it give us the same remainder, that means what? They point the same answer. Of course, clearly that means what? A figure 3 is same as a figure 2015. So basically what? Power 3 is same as power 2015. Of course, power 3, final answer here is nothing but 7. So Taylor so basically has a few different food to choose. So basically, so he can choose one meat. So basically, so for the meat, so total 3 types, beef, so chicken or pork. So he can choose one. So basically, so next one is so vegetables. So vegetables. So basically, he can choose 2. So I'm going to quickly put down. So with bean. So bean, and then corn. So potato. So potato, and also the tomato. So basically, he can choose the 2 different types. So another one is for the dessert. So we have 4 different types. So brownie, chocolate cake. So another one is the chocolate pudding. Another one is ice cream. So ice cream. So he can choose one from here. The problem is trying to figure so how many different meal he can choose. It's very clear. This is nothing but a multi-step process. So sigma 1. So first step is pick a meat. Problem C, he can only pick 1 because order really doesn't matter. They give us number weight and nothing but 3C1. So next one, he can choose 2 different vegetables. That means what? Nothing but 4C2. So next one is here choose one from a dessert. It's nothing but 4C1. I choose one from four different types that give a nothing but 4C1. So clearly this is a multi-step problem because what? Because so we need some meat, some vegetable, some dessert. If you choose only so dessert part, that is clearly not reach our goal. It's nothing but one step. So Sigma, he need solve three problems. If you just solve one, it's nothing but one step. So that's why it's very clear. For each choice is nothing but a step. Finally, of course, we need to multiply everything together. So multiply everything together, of course, of 3C1. Any number C1 is nothing but that number. How about 4C2? 4C2 is nothing but 4P2 and then divided by 2 factorial. 4P2 is nothing but start is 4, nothing but 4 times 3. Of course, 2 times 1 is nothing but 2 factorial. Of course, simplify nothing but 6. Of course, multiply 6. So any number C1 is nothing but that number. Of course, finally, figure answer is nothing but 72. So that is answer for this one. So make sure you understand how many liters of 90% alcohol solution must be added to the 50% of alcohol solution to produce 80% alcohol solution. So I will quickly draw some diagram so help you understand what's going on. So Sigma original, so we have what? We have 50 liters solution. So it contains 50% of alcohol. That means what? So Sigma, this part is contain 25 alcohol. Of course, that means what? 25 non-alcohol. The problem try to add something. So we need to add some solution. The problem try to figure how many liters. As we do notice, the problem already give us what? Alcohol solution for this one is 90%. That means what? Contain 0.9x so alcohol. And of course, that means what? 0.1x non-alcohol. So after you put everything together, so of course now we end up with what? We end up with the entire alcohol solution is nothing but 80% alcohol. I try to fully understand. So there's a problem. So next one, I'm going to quickly draw a table. So definitely you try to learn, organize your work. That's something definitely super useful. So Sigma, so in the first column, let's try to put a solution here. Of course, let's choose alcohol. So for this one, so another point is non-alcohol. So let's try to put another one is non-alcohol. So first one solution, we already know 50, of course, because it's 50%. That means what? It's nothing but 25. This is nothing but 25. Of course, we need to add something new. Of course, we don't know how many. Let's call this x. Of course, that means what? Alcohol nothing but 0.9x. Because what? This contains 90% alcohol. Of course, that means what? This one must be 0.1x. So Sigma, this one plus this one must be equal to this one. This one plus this one must be equal to this one. So Sigma, this are the teams we played. This is the team we win. This is the team we lose. Of course, win plus lose must be equal to the total number of games. So very similar to that type of problem. So next one is always try to figure one equation because we have only one variable x. So how to build equation? It's very clear. Definitely we need to use this information. We never use this one yet. So that means what? The total number of alcohol over the total number of solution must be equals 80%. That's how you understand this one. The total number of alcohol is very clear. Nothing but 25 and then plus 0.9x. The total number of solution is nothing but 50 and plus x. Of course, the problem is what? New solution contain 80% of the alcohol. That means what? The total alcohol over the total solution must be equals 80%. Of course, 80% nothing but equals 0.8. Let's quickly solve this one. Of course, in general, when you try to solve this kind of problem, always try to get rid of fraction. So Sigma multiply both sides by this one. Of course, this side is nothing but 25 and plus 0.9x. Of course, this one multiply this one that give us nothing but equals what? Equals 40. Of course, and then plus 0.8x. So next one is of course move this one to this side that give us what? Nothing but 0.9x and then minus 0.8x that give us nothing but 0.1x. Of course, put numbers on this side that give us nothing but 40 minus 25 is nothing but 15. So how to get x? Of course, the best way is what? You multiply both sides by 10. That give us nothing but multiply 10, find out here is nothing but 150. So we roll a pair of dice. So I'm going to talk about so A and G and H. Try to fully understand everything here. Space what A is water probability. Sum equals 4. Sum equals 4. So let's see how to solve this one. It's very clear. We need to try to figure total outcome. Total outcome is very clear. It's 6 times 6, which is 36. So in order to figure minimum condition, I'm going to use one of those 4 common strategies. First one is check one by one. So next one is what? Try to construct solution. Of course, another one is use parity property. Of course, another one is use complementarity. So that is super common way to figure minimum condition for this type problem. So clearly the best way for this one is try to construct solution. Clearly, and I give us 1, 3. Of course, next one is 2, 2. Of course, next one is 3 and 1. We have only 3 so minimum condition we can construct. That means definitely minimum condition is nothing but 3. Of course, simplify. Final answer here is nothing but 1 over 12. So problem B is talk about what are the probability. The first number is greater or equal to second one. So basically, what are the probability? First one is greater equals the second one. So still, the total outcome is nothing but 36. The question is how to quickly figure meet my condition. So I'm going to show you how to solve this one by 2 ways. First one, so let's try to construct solution. Clearly, we will see the pattern immediately. So if first number equals 1, of course, second number is nothing equals 1. Of course, first number equal 2. Of course, could it be 2, 1 and 2, 2? It's very clear. So if first number equals 1, we have 1 way. First number equal 2, we have 2 ways. So first number 6, we have 6 ways. That means what? It must be 1 plus 2 plus 3 all the way to the 6. That is our meet my condition. Of course, and that's about 21 over 36 divided by 3 divided by 3, and that's about 7 over 12. That is answer for this one. So I'm going to show you another way to think about this one. So we know we have total 36 pairs. First, could it be first number is greater than the second one? Could it be first number equals the second one? Or first number is less than the second one? That is very clear. Because the problem is symmetric. That means what? This number and this number must be exactly the same. First number equals second number, definitely one. This must be equal 6. So what that means, the rest must be split into 2 groups. So we have total 30. Of course, that means what? This is 15. This is 15. The problem trying to figure first one greater equals to the second one. That means nothing but 15 plus 6. That gives us the same as last solution, which is 21. Of course, final answer here is nothing but 7 over 12. So let's see what the probability. What the probability? Sum is a perfect square. As what the probability? Sum is a perfect square. Sum is a perfect square. Let's see how to solve this one. Of course, definitely we know total outcome is nothing but 36. For this problem, it's very clear. The best way is what? Try to construct solution, because what? Definitely is sum together larger possible is 6 plus 6, which is 12. So definitely is we have only a few possible perfect square. For example, could it be first perfect square is 1, next one is 4, of course next one is nothing but 9. Of course next one is 16. No way we get a sum to the 16. So let's try to construct how many for each number. Of course 1 definitely doesn't work. So because smaller as possible is 1 plus 1. Definitely cannot get 1. How about 4? Of course, could it be 1? Could it be 1 plus 3? Of course, could it be 2 plus 2? Of course, could it be 3 and plus 1? So we figure 3 as a minimum condition here. So next one, of course, how about sum together equals 9? So check 1 plus 8 definitely doesn't work because 8 is not a die number. So keep in mind, the die number must be between 1 and 6. Of course, 2, 7 doesn't work. Of course, could it be 3 and 6? Definitely works. So next one is 4, 5. Of course, next one is 5, 4. Of course, next one is 6 and 3. So clearly, there is no more. If you count, it's very clear. We have 1, 2, 3, 4, 5, 6, and 7. So we have 7 minimum conditions. Of course, final answer here is nothing but 7 over 36. So make sure you understand this one. What are the probability? The product is greater than 4. So follow our common sense. Definitely we have a lot of minimum conditions such that a product is greater than 4. So naturally you want to think about complementarity. Of course we know total outcome is nothing but 36. Of course total and minus wrong answer that give us what? That give us a minimum condition. So right answer is product greater than 4. That means what? Wrong answer is nothing but less or equals 4. So make sure you get this one right. Otherwise, definitely you will miss this one. So less or equal don't means equal. So next one, at this point, definitely is the best way is quickly so construct solution. For example, if the product equals 1, definitely is okay, 1 times 1. How about product equals 2? So definitely could be 1, 2, or 2, 1. So how about product equals 3? Of course, definitely could be so 1, 3. Of course, could be 1. So could be 3, 1. How about product equals 4? Of course, could be so 1, 4. Of course, could be so 2, 2. Of course, could be so 4, 1. So that's all if we get a product less equals 4. Let's quickly count 1, 2, 3, 4, 5, 6, and 7, 8. Of course, we figure 8 a wrong answer. Of course, that gives us a right answer, and that's about 28 over, so 28 over 36. So simplify divided by 4, we figure answer, and that's about 7 over 9. That is answer for this one. So make sure you fully understand. So eventually we have 2 wheels. So simple first one is so 1, 2, 8. So next one is 4, 5, 6. We get a number from here, so get a number from there at random. As part of trying to figure what the probability as we end up with even sum. Even sum. Let's see how to solve this one. First one, definitely is you need to identify this not equally likely situation. Because what? Clearly we have more chance to get 8 than 1. So in order to be equally likely, of course, we need divide this one into 4 equal area. Of course, that gives us what? So now that's about first number could be what? Could be 1, 2, 8, and another 8. So make sure you get another 8. So now, of course, those 4 numbers are equally likely. Because what? Because they have the same area. So next one, 4, 5, 6, of course. So now clearly figure what? So total outcome is that's about 4 times 3, which is 12. Let's try to figure minimum condition. So even sum, that means what? Could it be so even and then plus even, or could it be odd number and then plus odd number? So even, based on the first number is even. Of course, we have 3 ways. So next number is even. Of course, we have 2 ways. That means 3 times 2. Of course, we figure here is that's about 6. How about first number is odd, second number is odd? It's very clear. And that's about 1 way for the first step. That's 1 way for the second one. Of course, multiply together, and that's about 1. Of course, at the add everything up, that gives us one minimum condition is that's about 7. That means what? Probability is that's about 7 over so 12. So make sure you understand this one. So we have a wheel. So base one. So we have 4 numbers here. So 2, 3, 4, and 6. It's very clear. So this is not equally likely. That is first step. You need immediately realize we need draw a dot twice. That means what? We get 2 numbers. So basically, same board. That means what? I like to draw another one. So if you draw another one, it's much easier to understand. So I'm going to draw 2 because it's easier. To understand this problem. Of course, now we need to make equally likely. That means what? Definitely divide 2. So equal area. This is 6. This is 6. And 6. This is 6. Of course, here do the same thing. Of course, equal area. This is 6, this is 6, and this is 6. So now definitely this is what? This is nothing but our dice problem. First number could be so 2, 3, 4, 6, and 6, and 6. So next number could be so 2, 3, 4, 6, and 6, and 6. So problem C is try to figure what the probability the product is a perfect cube. So make sure you understand this one. Space one, 2 number multiplied together is a perfect cube. So clearly total outcome is nothing but 6 times 6, which is 36, because when we have 6 equally likely number, 6 equally likely number, of course 6 times 6, which give us 36. So perfect cube definitely is when you solve this one. So the best way is check 1 by 1. Why? Because clearly the pattern is not clear. So if it is a pattern is very clear, I would try to construct solution. But here the best way is definitely is check 1 by 1. So definitely is let's quickly check. So in order to make checking either, I'm going to quickly put down the possible perfect cube. Of course, 1. Next one could be what? Could be 2 times 2 times 2, which is 8. Of course, next one is 3 times 3, 3. Of course, that gives us 27. So next one is 4 times 4 times 4, which is 64. So clearly, larger possible here is 36. That means what? Definitely is impossible. So now let's see. So can we get 1? So clearly no way. Let's quickly check. So 2 pairs multiplied together. So give us those 2 numbers. Let's check from 2. Of course, 2 times 2 that work. Times 3 that work. 2 times 4 that works. Of course, times 6 that work. That means we have only 1 way here. So how about 3? Of course, 3 definitely times this one. No. So no, no. Of course, no here. So of course, that means 3 definitely doesn't work. So how about 4? It's very clear. 4 times 2, that works. That means definitely we have 1. So minimal accuracy here. Of course, clear. So everything else doesn't work. So how about 6? No way you get so those 2 numbers. That means what? We have only 2 so minimal accuracy. That gives us our final answer here is nothing but 2 over so 36. That gives us 1 over so 18. So make sure you get this one right. So flip a coin 6 times. Water probability exactly. So 3 tails. Let's see how to solve this one. So clearly, this is nothing but 2 counting problem. So sigma, if I flip a coin 6 times, how many ways are possible? That is our first counting problem. That gives us nothing but, so nothing but the total outcome is nothing but 2 to the 6th power. So second counting problem is nothing but flip a coin 6 times. So how many ways get egg? That is 3 tails. That means 3 tails and 3 heads. We know this is a super standard problem. We know answer here is nothing but 6 and C3. Don't multiply with any cells. Go simplify. That should give you answer. Let's see another one. So water probability, we get what? So water probability, we get at least 2 heads. So at least 2 heads. Let's see how to solve this one. It's very clear. The total outcome is nothing but 2 to the 6th power. So how about minimal accuracy? Minimal accuracy is nothing but the following counting problem. So imagine we flip a coin 6 times. Well, how many ways we can get at least 2 heads? Clearly we can do the case work. So first one is exactly 2 heads. That means what? Nothing but 6 C2. So next one is what? So 3 heads and nothing but 6 and C3. Of course, continue and nothing but 6 C4 6 and C5 6 C6. All you can think about this one is nothing but using complementary counting. We know total is nothing but 2 to the 6. Of course, wrong answer is what? Wrong answer is so no heads or only 1 head. That gives us nothing but minus 6 C0 minus 6 C1. So I prefer this one. It's a little bit easier when you do the evaluation. Water probability, we get what? We get more heads, so more heads than tail. So basically more heads than tail. So let's see how to solve this one. Again, the total outcome is nothing but 2 to the 6th power. So minimal accuracy more heads because we flip 6 times. That means what? Could be 4 heads, 2 tail. Of course, they give us nothing but so 6 C2 or 6 C4. Of course, let's choose 6 C2. So next one could be what? 5 heads, 1 tail. It's nothing but 6 C1. So next one is 6 heads, 0 tail. It's nothing but so 6 and C0. Of course, evaluate that is answer. So probability, what a probability? We get at least 1 tail. So definitely you want to think about the complementary counting. It's very clear. The total outcome is nothing but 2 to the 6th power. Total outcome is 2 to the 6th. Of course, minus wrong answer. Wrong answer is what? There's no tail. So think about all the heads. It's very clear. We have only so 1 way. Of course, simplify that give you the final answer. So imagine we have so 3 boys, 3 boys. So 3 boys and 3 girls. Let's try to solve. So first one, what the probability? We select 2 at random. So basically what we select 2. So at random. So at random. What the probability? Including 1 boy and 1 girl. 1 boy and 1 girl. Let's see how to solve this one. It's very clear. There's a nothing but 2 counting problem. So first one is nothing but. So imagine we have 3 boys, 3 girls. We want to choose 2 at random. How many ways are possible? It's very clear. It's nothing but. So altogether 6. Of course, we need to choose 2 and give us nothing but 6 and choose 2. So minimal accuracy is very clear. And nothing but we have 3 boys, 3 girls. We want to select 2. So how many ways get exactly 1 boy is 1 girl? It's very clear. This is our typical counting problem. And nothing but 3C1 and multiple ways of 3C1. Of course, simplify. That should give you answer. Of course, if you understand A, of course, you should have no problem with problem B. Of course, also problem C. So sigma. So typical problem. So definitely you can get there. So this is our point A, this is our point B, this is the point C. So basically, choose a shortest path from A to B at random. So what the probability? So basically, pass through C. Let's see how to solve this one. Again, this is nothing but 2 so counting problem. First one is, of course, nothing but from A to B. So how many shortest paths? clearly, they give us what? 4 east and 3 north. They give us Nasiba, so 7 factorial, and then divided by 3 factorial, and then divided by 4 factorial. Of course, here a Nasiba 7C3 or 7C4 because 3 plus 4 equals 7. So next one, minimum condition Nasiba, this problem from A to B, the shortest path passing through C. It's very clear. This is a multi-step. First step is from A to C. It's very clear. 2 east and 2 north. It's very clear. Nasiba 4C2. So next one, 2 east and 1 north is very clear. That's about 3C1. Of course, that give us a minimum condition. Of course, simplify. That is our final answer. So make sure you understand. So we have 1, 2, 3, 4, 5, 6 people. So imagine we have 6 people. 1, 2, 3, 4, 5, and 6. So they say it at a random, so in a circular permutation fashion. What the probability? So Jeremy and Ben are seated next to each other. So basically Jeremy and Benjamin are seated next to each other. Let's see how to solve this one. Always remember the best way for this one is you fix something. Once you fix one, so definitely the rest is nothing but our standard permutation problem. I'm going to fix Jeremy to here. So Jeremy has to sit here. Now, of course, total outcome is what? In nothing but, of course, we have 5 left. That give us nothing but 5 factorial. Minimum condition, of course, B could be here. Of course, now we have 4 people, 4, 6, and very clear is nothing but 4 factorial. Of course, B is here. That is another 4 factorial, of course, plus 4 factorial. So if you simplify here, a nothing but is 2 over 5. That is our first way to solve this one. So another way is think about we fix Jeremy here. So now Benjamin could be what? Could be here, 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 here. Benjamin can choose 5 ways. How many meet my condition? Very clear. This one and this one only. That give us answer at 2 over 5. So same, but definitely it's much easier. So we have 3 congruous circle. 3 congruous circle. So put into a rectangle. So put inside a rectangle. Basically, we select point inside a rectangle and random. What the probability? So fall inside. So those 3 circles. So there's nothing but talk about minimum condition is nothing but the area of those 3 circles. Of course, total outcome is nothing but the area of this rectangle. Because we know the dimension, of course, we can always pretend some number. Let's pretend this radius is equals 1. If radius for each circle is 1, it's very clear. Minimum condition here is nothing but pi. I'm going to give us nothing but 3 pi. So of course, total outcome is very clear. This is radius, that give us, this is 2, this is 2, this is 2, this is 2, that give us nothing but 6. Of course, multiply together, that give us a total outcome is nothing but 12. Of course, simplify here is nothing but pi over 4. So that is answer for this one. So we have 4 boys, 2 girls, 2 girls. We want to select 2, at random, 2 at random, 2 at random. So what are the probability, including 1 boy, 1 girl? Let's see how to sum. So that's one. So next one. Let's flip a coin 5 times. What are the probability, including exactly 2 tails? Let's try to solve this one. Another super, so 8.1. So let's see, problem 3. So in the back, we have numbers. So from 1 to 7. Jack picks 1 at random. And they keep it. So remember now, it's very clear. It's nothing but without a replacement problem. And Peter pick 1. So pick 1. So add a random. Let's try to figure what the probability. The product is what? The product is equals an even number. I try to solve those 3 problems. So first one is very clear. This is nothing but 2 counting problem. So think about the first counting problem is we have 4 boys, we have 2 girls. We want to select 2 at a random. So how many ways are possible? It's very clear. Combine everything together and choose 2. That give us nothing but 6 C2, which are our total outcomes. Minimum condition is another counting problem. Imagine we have 4 boys, we have 2 girls. We want to select 2, including 1 boy, 1 girl. How many ways are possible? It's very clear. A nothing but 4C1 and multiple ways are 2C1. Of course, top a nothing but 4 times 2, which is 8. Bottom ways are 6 C2 a nothing but 6P2 and divided by 2 factorial. Nothing but 6 times 5 and divided by 2 times 1. Of course, simplify is nothing but 15. So that gives us final answer is nothing but 8 over 15. So next one is again, it's a nothing but two counting problem. First one is a flip coin 5 times. How many ways are possible? It's very clear. 2 to the 5th power, it gives us 32. So minimum condition is nothing but another counting problem. Flip a coin 5 times. How many ways get exactly 2 tail? It's nothing but 5 C2. Of course, simplify nothing but 10 over 32. Of course, divided by 2, 5 over 16. That is answer for this one. Let's see how to solve the last one. So figure out the total outcome is nothing but, of course, first number could be all the way of 1 to 7. Of course, that gives us 7 weeks. How about next number? So clearly, Peter number cannot be same as Jack number. That means Peter number has only 6 weeks. That is something super very important. So product and even definitely want to think about the complementary counting. I'm going to use total outcome and minus the odd product, which is what? Which is our wrong answer. Clear is nothing but 42. Of course, 42 and minus our wrong answer is we end up with odd product. In order to get odd product, it's very clear. First number must be odd, and the second number is odd. So remember, odd and times odd. Of course, first number, of course, could be 1, 3, 5, 7. We have 4 ways. So second number is very clear. So Jack keep that one. So definitely one. So in the second step, we have only 3 odd number left. That give us 3 ways. That give us a total wrong answer and 12. That give us nothing but 42. And then minus wrong answer which is 12. Of course, and it divided by 42. Top is nothing but 30. So of course, bottom is 42. So simplified. So divided by 6. That gives us nothing but 5 over. So 5 over 7. So let's stop here.